the first thing I am going to do is I will share my screen because so let's see. Yes. Can you see my Teams? Oh, it doesn't let me do that. Okay. So, oh, Microsoft Teams here. The first thing I'd like to talk about is go to Teams. So Microsoft Teams is where you will live for the next year, at least. This is where our team lives. You need to talk to someone, chat over here. You can search them up. You click new chat, and I don't know why that's there left over, and you search their name. You go to Teams, you can find energy systems. Over here, oh, please, 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 please read this. We don't have this Teams chat set up for me to just put stuff and you not to read it. I know it sounds like it's more work to do, but like that is our form of communication. It's not like we see each other additionally like in person and I can be like, hey, I need you to do this. Like, no, this is like genuinely where stuff is happening. This is like I'm not like fucking around. Like it's actually like if I put stuff here, like I expect you to read it. It's not like I just write shit for the sake of putting shit up here. Um, if you go up here to the tabs, you're gonna find two really important tools, and I'm gonna stress this that you use these tools. So here, not as important, but very, very useful, access to your Google Drive, access to the textbook, access to the other textbook, learning resources, our document formatting guide, over here, Energy Systems homepage. And all the stuff that you're going to need is going to be here. I put the time to put it together so that, you know, it's going to be easy to find, so that it's easier for you guys to do the stuff you need to do. You need access to the Asana. It's going to be over here. It's fucked right now. Gotta fix that. You need access to OneNote. OneNote, very important. I said this last week. I'm gonna say it again. All of our meeting agenda stuff is gonna be in the OneNote. Everything. Meeting record. So at the end of this meeting, when this video is done recording, it's gonna be in here. All your updates is gonna be in here. Our agenda is gonna be here. Do you want to know how the next meeting is gonna progress? What we're gonna talk about in the next meeting is gonna be here. I expect all of you to, you know, at least take a look at this before you come to the meeting so that you come prepared. You know what you have to do, you know what's expected of you. And I already discussed the structure of each meeting and how each meeting is going to go, so I'm not going to spend time doing that right now. We only have half an hour. But again, all of these all the meeting stuff is here. And just to give you a quick example of how you want to use it, if you look at the meeting from last week, if I missed that meeting, I can come here and watch the meeting recording. There's a YouTube video provided, a YouTube link provided. I can see what they did, you know, see all the important stuff. That this is just the agenda, and then here's actually kind of what happened. So I'm gonna try and take notes and expect all you guys to update this OneNote. And so actually, if you go there, you go to energy systems meetings. Here is like, you know, put all your updates. It like if you did something, right, and you want to talk about it, what your update is going to be for this week, please put it down in here. If you so for I already set it up here. So all these teams who are presenting today or going to give updates, please if we weren't able to write all your stuff down here, please please write it down after the meeting in your own time. Like it doesn't take very long. All right. If you look down here, is literally just like a brief, you know, write up of what you did and what you told us that you have done today. So a UTHT kickoff event and video. So it has a recording of our kickoff event from yesterday actually, and that is going to be posted on YouTube at some point. And I encourage all of you guys to watch it because again, you're not just part of energy systems, you're still part of UTHT as a whole team. And if you want to know what the other teams are doing, it's pretty important that all of you watch that video to see the progress that we have made as a team in the past year, our goals and our vision as energy systems, but also that of the other teams and what they're doing. And because we're not just designing a battery system for our team. I mean, for just for the sake of it, we're designing it to be used in a pod. So there's a lot of other design considerations that you must make. And you're going to be able to understand the context of what you're designing a lot better if you understand what other people in the team are doing too. So I highly recommend that. It's 2 hours. I don't think you have to watch everything. There might be timestamps posted on it. Let's see. So yeah, off video, brief rundown of events and goals and objectives. So I will now pass it off to the battery charging team. What to give their updates. Whichever one of you wants to talk about it, go ahead.
All right, Keeg, do you want to share our PowerPoint or?
Oh, you want to share screen? Yeah, absolutely.
You could do it too, but.
No, I mean you're presenting, so you should share.
All right.
I will just try to take notes on the thing about what you talked about, what you're talking about.
Sure. Sure, whatever. All right, cool. So yesterday, kind of like the battery charging team, we just got together to kind of come up with like the plan of attack. So what we're going to be trying to do in like the next short little while on like how we're going to be approaching this problem. So yesterday we just like came together and kind of came up with some like research questions and other considerations that we think are valid and also important to solve and I guess consider. And so right now we're kind of just going to the investigation phase and just figuring out more about them and seeing what kind of roles they'll play in the design process. And then from there, it's kind of like specifying what's going to be in like our theoretical charger. So what would we want to see out of it and like how would it be used, etc. And then from there, I guess we'd go into like more of like the actual hardcore design where we're coming with like how are we going to like build it? What is it going to like consist of? What parts, what components? How is it going to like be put together? And then use like simulations, diagrams as like supporting evidences and details. And then if we see that there's some issues along the way or things that can be improved, of course, we'll iterate the process. And then I guess just some of the major questions we had. There's no need for like any of us to like discuss it now. We could always have like an offline discussion, but just some things that we're thinking about. And like this isn't the like exhaustive list. There'll probably be more we'll find along the way. And this isn't even all the questions that we currently have as well. But yeah. And so this is just in the Google Drive if anyone wants to check it out later.
Nice. Awesome. Good stuff. So you should totally talk to June, or you can talk to me. I've already got some information from him, and I think he has a lot on his plate with the the high voltage, the control systems.
I mean, we can have a touch point. Like we can schedule one afterwards. It's fine. I think it'd be interesting to just get everybody on the same page.
Yeah. At the end of this, everyone on the charging system, if you don't mind staying at the end of the meeting for like another 15 minutes, we can talk. And June, of course, you too. Yeah, we can talk a little bit. All right. So low voltage power distribution. Sorry, LV power distribution team, you're up. That is Jasmine and Shash. Shash is once again not here. Is she? Oh, she is. She is. I just didn't see it. It's down there.
I'm
very
here.
small.
Hi.
Yeah, so you guys, which one of you wants to go up? If you want to share your screen, show us some of the work that you've done.
I don't really have much to show because I just got the power requirements. Like I got the information for the cooling system power requirements yesterday. So I haven't like updated that yet.
Any new converters or anything?
For me, I was responsible to find like possible boost buck converters for like 24 volts and 12 volts and 5 volts, and I found like potential ones but not a lot because there's not a lot of options on AliExpress that like satisfy the requirements. So I'm like currently still looking for more possible parts. But yeah, I found like ones that will do, but I think the more the better.
Yeah, have you tried other other vendors
I
on
tried,
Amazon? Sometimes you might be able to find some
yeah,
good ones.
I tried
Did you,
Amazon, but they're more expensive. And I try like websites in Taiwan, but I don't think they ship to Canada. So
I mean, you could always ship it to yourself and then you eat it here.
yeah, I was thinking that, but I'm leaving next week, so
Ah,
I don't think that'll work.
okay. Yeah, we can talk about logistics later. We have a whole business team to handle that. So actually, if you can find a part, like if we really can't find the other parts, it's okay. I think uh and this is to make sure that like it fulfills the power requirements. Sometimes the power requirements I gave you might be like too low
Yeah,
or too high in the
Mhm.
sense that like say you needed it for to handle 20 amps. They might make boost buck converters, but like just for a higher current than what I gave you for a higher power rating because the voltage jump is so big.
yeah,
So you might want to remove that from from your search constraint. I get sometimes I get better results with that.
okay.
LV all right. Yeah, so if you guys just can top up your updates. So Shash, is the power distribution like complete? I mean, is the power like breakdown complete? There's not gonna be, you don't think there's gonna be any other like sources of power or things that are gonna be drawing power from our system?
I don't really have the information for one of the components for fans for the cooling system because they haven't like decided that yet. So I don't have like the final numbers yet.
I see. For the fans.
Yeah.
Yeah. So for that, just try to estimate it, you know. I think we're gonna stick with standard 120 mil fans. So just search, and I think we're only gonna use like 2 of those.
I thought. Oh, okay. Two. Not four.
Oh, I don't know how many it is. However many of those fan, like, he hasn't decided which specific fan, but there's a type. They come as like a standard type. Like it's like it's
Okay, so
like
just look for a generic one.
yeah, like a 120 mil fan.
Okay.
Yeah. So yeah, all right, LV battery system team.
Yeah, so since last week, we've been working on the wiring diagrams and how to like exactly the configurations for the series and parallel wiring for the low voltage pack. So I'll just share the wiring diagram that we came up with so far. So it's gonna be like this is what we have right now at the moment at least, and we're thinking about getting two. So each pair of cells is gonna be in parallel, and then each parallel is gonna be connected in series with these. Like you can see the series connections, and there's so with each pair, this makes it so that we have the 6S2P that we need. And so I tried to make it so that we had like hopefully there'll be like the least amount of overlapping as possible because that will make it easier to assemble, and hopefully that will make it less likely to make mistakes or like less likely to make short circuits while assembling. And so our next steps are going to be making the wiring for the BMS, and then we're going to add the Arduinos and the other circuit components to the wiring. And if Mayank wants to add anything, go ahead.
Oh, that's pretty much it. I don't know if y'all hear me. My internet's pretty bad.
Yeah, I can hear you loud and clear. Do you think you guys can so Harsh, you said you know how to use SolidWorks and stuff? Do you want to start
Like somewhat, yeah.
you want to start CADing out the so you can get the 18650 cells easily, and you can find a 3D model of the cell holders pretty easily too. You want to start like CADing it out, and then trying to figure out those, like, you know, the 3D, those like drawings that you guys did before, try to turn those into models and see which ones look the best, or see you know, yeah, and then try to do wiring.
Should we do wiring first, like with the BMS and everything? Because right now I'm not sure where the BMS, where the Arduino and everything would go in relation to the
Yeah,
other.
I think we can get the CADing like next week and like just finalize on the BMS wiring first.
The BMS wiring is pretty straightforward here.
Yeah, that's
You're gonna-
fine, but like just like where everything would go, because we have sensors and everything, right? So like we need to figure out where's the most efficient place to keep it, at least
I see.
within this pack.
I would put so you're using the TMP 36, right? Or whatever.
Yeah, we plan on putting like 3, one for every like cell holder, basically one for every 4 cells.
I would put yeah, you can do that.
Mhm.
Like if you're gonna do that, you might as well put it in the middle. What I would do is, you know how the shape is rounded? It's like rounded on the one side. You could put it on like between 2 cells on each holder on the opposite ends. So you'd have 2 per holder, so that like there isn't a cell which isn't touching a temperature sensor. Then the temperature sensor will obviously heat up to the highest cell temperature.
Is that too many though? Or like
That's 6. That's fine. The Arduino can
that's 8. Oh no, 6, my bad.
the Arduino can do like I think I have it hooked up to 7. Oh yeah, to 7 on the high voltage module. So you can use the same architecture, like the same layout that I use for the high voltage battery packs. If you want to take a look at that, the
Yeah,
notes should
seen
be
it.
yeah. So that one can handle 7. This should be able to do this. It can do 6 easily then.
All right.
Yeah, because you're gonna use the same. You're probably gonna use the same thing, Arduino Nano.
Okay, yeah, it's not like we can do that.
Okay, yeah. And then placement wise, just put them in between the 2 cells on the opposite ends.
Yeah, like we got that. Like it's in between every like smaller box, right?
Yeah.
Mm-hmm. Okay.
Yep.
And then yeah,
Yeah, that's sick. That's all I think we have to say.
yeah. So if you guys can just start CADing it out next week, then you have that figured out now.
Yeah, exactly. I think by next week,
Yeah.
or like maybe soon, we'll have like a CADed model. That'll
Yeah.
be it.
That'd be nice to see your CAD model next week. Sure, that's good. Oh, also the battery charging system, please. You can link your presentation into here so that if people are reading the meeting notes, they can just click on that link. Like make it one of those links that anyone can access, kind of thing. Like you can write like presentation or something, or just like what I like to do is just change the heading in the updates into a hyperlink.
Are you talking to us?
Oh no, for the battery charging system team.
Okay.
But yeah, that's good. That's good stuff. If you can make that wiring diagram a little smaller and then include the BMS onto there, just make a box with wires coming out of it. Do you know what BMS you're using or roughly how it's supposed to be wired up?
We know
I
which
know how
one
to
we're
wire it.
using.
Oh, you know how it's going to be wired up? Okay, awesome.
Yeah,
I
Harsh
know
knows
I know how
how it's gonna
BMSs
be
are generally
wired,
wired up. Yeah.
and yeah, he had the other one wired too. And I'm pretty sure we know like which BMS we're using. It's like the 20-volt one. Like I have a link in the doc, so I think we got that.
Okay,
Yeah.
yeah. If you can link that doc into this meeting update, that would be nice. And then just write down a little bit about what you did today.
We
Sure.
haven't really changed that. Like a lot of it needs to be changed, but after we do, we put it in the
Yeah,
doc.
no, but like just write that like no, like in the OneNote.
Yeah, yeah.
Yeah, like just write that like you made an actual wiring diagram. You know, that's all that needs to be there.
Okay.
Made wiring diagram on
Okay.
AC EDA. All right, so I want to introduce you guys to Hamza. Hamza is really great person who is our chief mechanical engineer, and he's been helping us a lot with trying to figure out how to mount our parts that we make onto the pod itself. Hamza, if you want to like turn on your mic and camera, introduce yourself to the team, and let them know what you do.
Yeah, sure. Hi everyone. I'm Hamza. I don't know if you guys see me. My webcam's really shit. Oh no, it works. I think so. There we go. All right. Hey everyone. I'm Hamza. I am the chief mech engineer for the Pod One. So Anaki told me that he wanted me to come in for this meeting to go over not go over the CAD, but just to introduce the point man for how you guys are going to get your CAD files onto the actual pod. So, I mean, generally, what I understand is that, and how the other chief mech engineer did this before this, Danny, is that once you guys are done with like CAD files and you have like assembly done, or if you guys even need pointers, you guys can come contact me. But the main job would be just when you have a full assembly file done, you will hand it off to me, and then I will find ways to position it into the full pod model. I have the actual pod model open right now if you guys want to see it, but it's basically most of the work is just like getting holes into the sheet metal CAD and just placing it in. But it's something you guys can work on too. And my main priority is to get you guys more more integrated into CAD and more knowledgeable in how to use SolidWorks or CATIA or any other CAD software, because it's a very useful skill to have in engineering. So yeah, that's basically the CAD side of it. Nagi, do you want to add in?
Yeah, okay, so like I said, Harsh and Mayank, you're gonna soon be I'm just gonna give you guys a little rundown of what's gonna happen next, what's gonna happen over the next couple weeks. I will share my screen again, just my entire screen, and then let's see, systems kickoff. Oh, here we go. So just briefly, so here is our energy systems mission and vision. But more importantly, let's go over what our goals are for the next month of September and the month of October. So from the meeting before, I've already split you guys up into these teams. This structure has slightly changed. I've added another sub team. Truman is in the cooling system sub team there. That's what had to be added. And here it's color coded based on which sub team you are, what you will be doing, and what I expect you to finish by the end of September. And then here outlines what you would be expected to complete or what our goals are as a team by the end of October. So low voltage power distribution team, I'm gonna go back here, purple. Inverter control systems, red. High voltage battery team, green. Charging system, blue. And then low voltage battery team is yellow. I should have it's over here also. I'm gonna over here. And I've kind of split up how, if you're kind of curious as to the whole high level overview of how our pod works, our energy distribution system works, I have color coded like the different components depending on what you're working on into these different sections, depending on like the sub teams. And so here we're going to see that those same teams now translate into actual goals that we want to hit. So by the end of this, I want the low voltage battery to be designed and the high voltage battery modules to be done being designed. And what do I mean by design? I know it sounds really like arbitrary. It's like, I know it's an iterative process, but I hope that for those two teams, we can finish up at least some sort of like bill of materials. We start to get to part sourcing and CADing. And for the purple team, the low voltage power distribution team, hopefully standardizing some sort of part sourcing method so that when you get your part, so that when you have to get new parts in the future, and you can help out all these other teams, they need to buy parts too for their stuff. You will have a fast way of doing it, and a fast way of putting it into the spreadsheet. We have all the spreadsheets set up with all the key parameters so that we can look through it and then pick only the best ones. For the blue team, the charging system team, you've already, so by the end of September, you would have begin charging system investigation, figure out your requirements. It's pretty evident from your presentation, you're on the right track. And then same with the red team, investigation to the control systems and how they work. I know it's a little long, it's okay. And actually this week I'm gonna set up a meeting for you guys with the electronics team and software team who are gonna be working on it too, because like one of the questions I think June brought up was like the control system has a pedal input because it's meant to be used in a car. So what is our pedal input? How is the Arduino going to interface with the motor controller on the inverter? All right, and by the end of October, I would like a CAD and a bill of materials completely done for the high voltage module. And that's what a BOM stands for if you're not sure. And high voltage DC power strip to be started designed for like for the pod, but that doesn't take very long. And that's also going to really depend on how we intend to implement it in the pod. Let's see. And so for the low voltage power distribution team, I hope you can start to CAD. I wrote low voltage battery CAD, but I hope you guys can CAD your low voltage system, and that you can also and that you would have all the parts sourced already by the end of October, and that you can help with the low voltage battery system team how to CAD. Although now that I know how that Harsh knows how to CAD, might not be so much of an issue, but I hope you guys can collaborate on that, because as you can see, your systems integrate a lot with each other. So one of the main things is figuring out how is this going to connect to these? How is the battery going to actually end up connecting to the low voltage power delivery system? So for charging system, I hope you guys can shift from a stage 1 to a stage 2, 3, 4 cycle, kind of like what the low voltage battery design and the high voltage battery design teams are on right now, where you would start creating block diagrams and maybe some rough wiring diagrams of like, oh, how is the power supposed to flow? What is the kind of like output we expect from this? Any rough calculations, very rough simulations if you want to, on like multi-sim or MATLAB, of the different circuits, or really sort of like setting stuff in stone. And for the inverter control system team, I hope that you guys can also shift to a stage 2, 3, 4, and 2, 3, 4 is this whole thing where you move to a cycle where you're iterating your designs, and you guys seem to be on the right track for that too. And so, block diagrams of all the different control systems that we have, and rough wiring diagrams. How are those? So what are the outputs and the inputs for all these different things, and where are they supposed to go? Where are they supposed to connect to? What kind of connector are they connecting to? Is it the amp seal 25 pin or the 35 pin? And or maybe a CAD of the circuit board, but I think it's more important that we get the block diagram and the fundamentals of the control system down first. Yeah. And then at the end of October or mid-October, we will reconvene and then establish what our goals are for November and then maybe December. So yeah. Any questions? No? All right. So good meeting, I guess. Everyone, you can leave. You're free to leave. The charging system team and June can stay back a little, and we can talk about the thing you mentioned earlier.
Bye.
Bye, guys. Oh, also, Brian,
Bye,
quick update. I have your like. Oh, he died. It's okay. I have these. Have any of you guys used like fake Arduinos?
Oh, the tiny ones?
No, I got the Elegoo ones because they got more reviews. And the cost difference was like $1 for a piece, and I was like, it's fine.
Does it work?
I don't know.
Pretty sure it should be the same thing. Like Arduino isn't like a thing. It's just like an open source.
Yeah, like the thing is, it's like it's locked. A lot of people were saying like you can't use like the latest Arduino like IDE for it or something like that, and you need to use like an older bootloader. But yeah, I have Brian working on that, so that's
all right.
So yeah, where were we on discussing the charging system? Oh yeah, pull up your questions again. I think we can answer some of those here real quick.
Yeah, give me a second.
What BMS did we decide?
Yeah, sure. That's some of them, and then I believe we have a few more Google Docs too.
Yeah, can you pull up the master list of all the questions?
I'm gonna answer.
We don't really have like one master list. They're spread out over a few documents.
Oh, okay.
So the high voltage pack and the low voltage pack are equipped with BMSs, and they are top balance. BMSs are equipped with top balance BMS, and they do have fuel gauge. The low voltage system is going to be equipped with a fuel gauge.
Okay.
Yeah. It makes more sense for that to be on the chargers too. I mean, on the battery itself too, right? Because you don't. So then you can use it anywhere, I guess.
Yeah. I guess the next question after that one was like sourcing parts versus designing them ourselves. And so judging from like this meeting, I think the general gist is we would probably want to like look for pre-existing parts as much as possible.
Yeah. So especially with these like high power things, it's like you could make it, but you're not going to be making the safest thing, I guess. And it's also probably cheaper just to buy it. However, June, you want to tell them about your what you're doing, what you did?
So bit of backstory. We're converting a car to be electric, and so for the charging system, we have similar constraints to the Hyperloop in the sense that we don't have that big of a budget, and our expertise is limited in the sense that we can't design high power components. So what we did was, we don't even have a BMS, but we took two server power supplies, 1 kilowatt each, and hooked them up to a ISDT balance charger that does like 500 watts of charging, which is fine for our purposes. And so we took two separate power supplies, plugged them into two separate balance chargers, and then plugged the two power supplies into the same outlet. And one of the power chargers blew up. Well, they didn't blow up, but the XT60 connector caught fire. Charger was fine, but we still returned it on Amazon. But anyway, yeah, the sellers are getting screwed, but it's a dog world out there. But so yeah, that's what we did. We hooked up two power supplies and two balance chargers to the same connector, to the same outlet, and one of them sparked. So what we did was we bent out the ground pin on the plug. So it's just the two prongs on the top and not the middle one on the bottom. And now it works. Now it works fine. Nothing's shorting, nothing's catching fire, nothing's sparking. So
Wait, it was only happy when you remove ground.
yeah. It's jank, but yeah, we just broke the pin off, the ground pin off, and it's working fine now, and we haven't died. So yeah. Now I don't know if it's specific to our setup because we do have a fuse in line with these ones, and I don't know, maybe like, and our car's negative terminal is grounded to the frame, so maybe it's shorted out on the frame or something. I don't know, but something to keep in mind, I guess. But for sake of simplicity, yeah, honestly, like we might even be able to get away with this because ours is a 7S pack, right?
Oh yeah, we have 7S, 4P. Like if we're just trying to charge one module at a time for the high voltage system.
Right.
So yeah, I guess that's another question as well. Like, do we want a different like charging system for HV and LV, or do you want something that's similar, or one that can be used for both?
Ideally a different system, but I don't think they would be very different from each other, if that makes sense.
Okay.
So like, if we want to just go with something we can buy ourselves, like the balance charger we're using can do up to 8S, I think. And it does 500 watts, and it's got built-in short circuit protection, temperature protection, user adjustable charge settings, user adjustable voltage cutoff. It's got all the bells and whistles and software updates. So, and it's $80. So like,
I was thinking we could get a couple of those because we have 10 modules. We can get a couple for diagnostics and testing, and like when we're first charging up all the packs together to see how the protection circuits are going to perform.
Yeah.
And what parameters we can set that are safe for charging.
Yeah.
But I want us to also have a charging system that like it won't need balancing because our BMS is already balanced, but they would have like current protection and like you can choose the current and voltage settings for those chargers that we make, and so that like we can charge all 10 modules at the same time, for example, or we can charge 1 or 2 modules at a time if we wanted.
Yeah, like they all have different outcomes because like charging 1 or 2 at a time, like that can also make it like easier for us to like top them up and make sure we get like maximum capacity.
So I was thinking something which is like scalable, so that we can like just make 10 of those easily if it's cheap enough, or like a big long thing, like in did you guys ever like have like those computer racks in high school?
No.
Or like a okay, but there's these like here. I know this is like a bad example, but it's like computer charging rack. Computer.
Like for the netbooks.
Yeah, for the netbooks.
Yeah.
Oh, yeah.
Yeah, so those had their own individual chargers, obviously.
Yeah.
But I was thinking, like, I know for this it's gonna be a lot more complicated because you don't want to have an individual power supply for each one, but at the same time, we need some way to maybe not like that, maybe something closer to this. but at the same time, we need some sort of way to
So,
like maybe I want to charge one at a time, or I can charge 10 of them. Like it shouldn't matter.
so the way the BMS is set up, I mean, you guys are using like the Dolly BMS from AliExpress, right?
Yeah.
Yeah, I think there are tests online on YouTube where the guy just plugs it into a DC power supply. Like it's not like no constant current, no constant voltage settings or whatever. It's just he just plugs it into the voltage that it needs, and the BMS will take care of everything else. So if that's the case, then we can just get a bunch of cheap like laptop power supplies and strip the wires, maybe make and cut it and solder it onto XT60 connector, and we can just plug it in.
I like that idea.
Yeah.
If you guys want to investigate that, that is a good potential.
It's actually really funny you brought it up because I was watching a video yesterday where someone did that and then charged up a car battery with it.
Yeah. So a car battery is sketch because you do need specific charging curves, or else the hydrogen inside the lead acid battery will start to bubble off and it might catch
Mhm.
fire. But anyway,
Yeah.
For lithium ion, yeah, because we have a BMS protection circuit, it should be fine. I was thinking of using this the exact same BMS for our electric car and trying to do it the jank like cheap way that's still reasonably safe and so we don't die, and came across that video. If we can do that, that'd be the easiest way. And then honestly, like if we can get like a fireproof or like a explosion proof cabinet where we can place all the modules and have them charging at the same time, that'd be clean.
Also, Kiki, by the way, for the batteries, do you guys have the SOC VOC curves?
Yeah, it's the SOC curves and VOC curves are in the thing. It's in the if you go to the high voltage module in the OneNotes, like if you go to
Mhm.
high voltage system in the OneNote, share my OneNote screen. So here, you just go here. I'm in the OneNote already. So if I just go to our page and then I go to energy systems, that takes me to the OneNote. It's up
Yeah.
here. And then I put it down here, I believe. Oh, I didn't.
Okay. But is it just like a
Bad.
curve or does it have the values with it?
It's a curve. So I tried to use this like vision algorithm that would make a curve based on what it saw on the picture I gave it. I actually have the data for one of the curves.
Oh, it worked out.
Yeah, I had to fix a few things myself because let's see. But I in this notes dump over here, this curve is actually it. We're using the Samsung 18 INR 18650 25R. It's a
Yeah,
standard
yeah.
cell. So there's a this thing is really oh yeah, this website, I think you guys have one of their images linked, but this website has the discharge curve.
Mm-hmm. All right, sounds good.
Yeah. Like you need to see what the voltage is over the time, right? Or like as it's being
Well, that
discharged.
and like also later on, you can do pulse tests to figure out the resistance of the batteries,
Mhm.
and then you can also use that to figure out limitations in terms of charging, or like also
Yeah.
just how much is lost. Yeah.
Oh, I think
yeah.
that's where the balance charger would come in helpful because they also do resistor measurements.
Mm.
Yeah, and actually, so originally, like the max charging that these could take is like, say, because we're doing 4P, each one is 4 amps, like rapid charge, whatever
Yeah.
the fuck that means. But and so 4 together, that's 16 amps. But then the BMS that we have maxes at 15 amps charging. However, I took a look again at the power requirements. I just realized you weren't seeing the other thing I was showing. But I'm just gonna share my whole screen, like fuck it. So here, this website, really good, and it's linked over here. But I realized the new power requirements, or I was looking at the power requirements, we have to revise it slightly. The new BMS is gonna be a 60 amp one.
Oof.
And I think 60 amp, 7S, high current, no. Yeah, 60 amp. But anyway, the thing is this, oh, it has a table somewhere. Oh, it's not here. I was looking at the table earlier.
All right, but like, what's in the table then? You can just explain what was there.
It has like the max charging that it would allow, and
Mm.
it has a built-in current shunt, so it's not like to actually like cut it off from overcharge or over discharge. Like if the current is too high, the charging
Mhm.
current or discharge current is too high, it's like pretty solid. I don't know why I can't find it. Okay, here it is. Well, this is the spec for 6S, but you kind of get the idea. I think it goes up to like 30. Yeah, it goes up to 30 amps. It'll let you do 30 amps. I don't know if like that's continuous charge current or if it's like pulse charge current. Like if it will notice if you did pulse charging. But yeah, that's just something to keep in mind, that when you do set up the testing setup, it's not gonna. I don't know how the BMS is gonna respond.
We can do some
Yeah.
tests.
All right.
Yeah.
Yeah, sounds good. Oh, also another thing is, I think it'd be nice if the BMS could, I mean, if the charging system, you could like plug it in, and you know how like it might take really long to charge, or at least sometimes you want to try like a really slow charging method for whatever reason. That, like you said, you want to use a fireproof cabinet and everything, and we can have some sort of monitoring system so that we can like leave and it can just stay there charging overnight.
Yeah. It'd be cool to have, I mean, this is just tacking, like, we gotta avoid, we have to avoid project creep, because this is what happens, you know, projects keep getting bigger and bigger, but
Yeah.
it would be nice to have, or maybe not even nice, but it'd be interesting to have a particle photon, like a IoT connected device that monitors the voltages. It could be a simple thing that monitors the voltages of each pack and sends it to an online dashboard that we can just check up on, like log into and check up on UV dots or something.
Yeah.
But that's like way out there. It's not a priority.
I was thinking of I'm gonna add a breakout VM balancing like connector for the high voltage modules, so that it, when regularly, it would just use the BMS of the battery. It would use the built-in BMS, but if you plugged in, you could plug it into the ISDT balance charger, and then you could also you could use that breakout connector to balance the cells, or like just take a look at the voltage of each individual cell.
Yeah, that'd probably be a much simpler solution. Yeah.
You'd have to like look at it there, and then you just point a camera at that.
Yeah, which is fine. Oh, but like, yeah, I don't know, that works. I mean, it depends on what we want, but yeah, that would work.
All right. Yeah, sounds good. You guys are on a right track, by the way.
Yep.
Really good stuff. I'm very impressed. Yeah. I'm very excited to see what you guys come up with.
All right, cool.
Dude, a rolling fireproof cabinet. This is gonna be sick.
Okay, I don't know if it has to be rolling, but you know, that makes more sense, because I don't know if our lab space, we're actually gonna like, it's gonna be like a permanent workbench kind of thing. It's
So like, do we want to design for say like Toronto lab versus like actual like competition scenario?
Yeah, that's another thing. I was thinking that I think it's nice to have the cabinet because we don't have a set workspace.
Yep.
So we need to be able to wheel this thing around. Like, never thought about it, but that makes it. I think we would have to be able to wheel it around. And if we did go to competition, we get time. We get like an entire day or two, and the track is at Waterloo now or whatever. But if the team, like whoever does it, goes out and does it, the battery's only gonna last like 8 minutes tops.
Mm-hmm.
So it'd be nice to have that charging system.
Yeah, so it's nice to have the charging system there, so you can just charge it. I don't know
Yeah.
how long. I don't. If we, I think if you charged each module, it's 500 watts. About. I don't know how fast we can charge the modules exactly. But yeah, then they could like test it, go out to eat lunch, and then come back and test it again.
Mhm.
Instead of like, oh, you just did it one time and you're done.
You're done for the day. You gotta go back.
Yeah.
And then I guess like depending on like how long we want in terms of charging, then it just changes like how many modules we want to charge at once, or like how many
Yeah.
chargers we have.
Yeah. And I was thinking like we could even have like more modules because so we can just put them in parallel.
Like technically, we can just connect all the modules in series, and then it would just charge through that with one current.
Yeah, we could do that. My only concern with that is a 300 volt charger. Doesn't sound very safe.
Yeah. Or otherwise, it'd be pretty slow.
I mean, yeah, like
not
so
necessarily.
what power supply are you gonna use for that?
So part scarcing, all right.
That's a 9 kilowatt power supply.
Dude, that's.
Are you gonna daisy chain the? Are you gonna daisy chain the server power supplies?
Except you can't.
All right.
Yeah, well, it's. Yeah, sorry.
No. I said like all right, as in like like all right, we'll look into it.
I mean, yeah. Ideally, if we can charge per module, that would be very nice because we're definitely gonna have more modules in the future, and being able to recycle that technology, or like say we make new types of modules in the future, and then it could just use the same charging system would be really cool.
Yeah.
Yeah. Right. Otherwise, good stuff. Have a good weekend, guys.
Yeah, you too. Have a
too.
great weekend, everybody. And yeah, if you guys have any questions or anything, shoot me an email.
Or message him on Teams.
Or yeah, exactly. That's what I meant. Yeah, Teams is the way to go now.
All right.
All right,
Bye,
guys.
bye.
All right. See you, everyone. Have a nice weekend.
Bye.
Thank you. Bye bye.
Easy.